Good evening, Naganadhipataye. Good evening to all. Yes, good evening, Lalitha Ditya. Good evening. Good evening, good evening. Ask. Any one of you can leave a message in the group. The class has already started. Everyone need to join. Good evening. Children, in the group I kept 4 polynomials for which you need to draw the graph. So in the morning I told you that there are 4 concepts in the polynomial. First one is graph, second one is finding zeros, third one is relation between zeros and coefficients, and fourth concept is problems on zeros. These are the 4 concepts. I told you that which are there in your 10th class syllabus. This one I gave you 4 polynomials that you need to draw the graph of it, and we will decide after doing that one graph. We need to discuss about that one. Here 4 or 5 points are there, we need to discuss. Now about this one, finding the zeros of given quadratic polynomial. As I told you, the general form of a quadratic polynomial is ax square plus bx plus c, where a, b, c are real numbers and a must not be equal to 0. You cannot take 0 in the place of a. You cannot take 0 in the place of a. What happens if we take 0 in the place of a? See, 0 into x square plus bx plus c. This is nothing but bx plus c, which is not a quadratic polynomial, it is a linear polynomial, degree 1 polynomial. Okay, when a is equal to 0 in ax square plus bx plus c, the quadratic polynomial, it becomes a linear polynomial. It becomes a linear polynomial. So a must not be equal to 0. But b 0 avachcha, c 0 avachcha. What happens when b is equal to 0? If b is equal to 0, then ax square plus c is remaining. If b is equal to 0 over here in this polynomial, then we will be remaining with ax square plus c. Can we call it as a quadratic polynomial? Ax square plus c. Can we call it, children? I'm not getting any answers. Ax square plus c. Is it a quadratic polynomial or not? No one answering? Indrani says yes. Yes, it is a quadratic polynomial because if you see the degree of the polynomial, it is 2 only, na? Degree 2, here exponent 2 and here exponent constant. C is a constant, its exponent is 0. So 2 comma 0 are the different exponents. They are whole numbers. So highest exponent is 2. So it is a quadratic polynomial. Highest exponent is 2 only, na? It's a quadratic polynomial. Even though b is 0, ax square plus c, we can call it as a quadratic polynomial because its highest exponent is 2. Now, what happens if c is 0 in this? What happens if c is 0 in this? In ax square plus bx plus c? What happens if c is equal to 0? What happens if c is equal to 0? So we will be remaining with ax square plus bx plus c is equal to 0. Ax square plus bx is equal to 0. If c is equal to 0 over here, we will be remaining with this one. Can I call it as a quadratic polynomial? Can I call it as a quadratic polynomial, children? Yes, we can call it as a quadratic polynomial. So, we have 3 different forms of quadratic polynomials. One is in the general form, the other one is this one, and third one is this one. So we may get problems, or we can get problems in 3 different forms to find the zeros. The given problem may be like this, or like this, or like this. I will give you examples also. It may be like this: 2x square plus 7x plus 6 is 6, a polynomial in the general form. A polynomial in the general form. Second one is like this: 2x square plus 4. And third one, 4x square plus 5x. So these 3 polynomials, why always plus? We can give negative also, no problem. Or even we can give here also negative. Minus 4x square minus 5x. So we may get 3 polynomials. All these 3 are quadratic polynomials only. So our problems may be in these 3 forms. Okay? Now, so what we are going to do first, we are going to find out the zeros of the given quadratic polynomial. We are going to find out zeros of the quadratic polynomial. Okay. How to find out the zeros? Before going to that, let me explain what is a zero. Suppose there is a polynomial like this, a linear polynomial. Now, what is the zero of this polynomial? What is the zero of this polynomial? Anyone? What is the zero of x plus 3? Ashi says 1. Amulya says minus 3. Who is right? Chirag says 1. I am not asking degree, Chirag. I am asking zero of the polynomial, zero of x plus 3. Okay. Let me explain the meaning of zero. What is the value of x such that when we insert that value in the place of x, the total polynomial becomes 0. The total polynomial becomes 0. What is the value of x such that when we insert the value in the place of x, then the total polynomial becomes 0. Such value is known as zero of that particular polynomial. Once again, a value or a number, when we replace x in the given polynomial and simplify it, if we get answer 0, then that particular value, what was inserted or what was replaced x, is known as zero of that polynomial. Here everyone says minus 3 is the zero. Let me see. I am replacing x with minus 3. Minus 3 plus 3. I am replacing x with minus 3. Minus 3 plus 3 0 only, na? So minus 3 is 0 of x plus 3. This is what we have to understand. Minus 3 is 0 of x plus 3. Okay, na? Now, in the same way, we are going to find out the zero of a quadratic polynomial. The zeros of a quadratic polynomial. First of all, how many zeros it will have? How many zeros it will have? See, we know the degree of the polynomial. Degree of this polynomial is 2, na? So the number of zeros it is having is also 2. Number of zeros it is having also 2. If the polynomial degree 3, it is having 3 zeros. Degree 4, 4 zeros. Degree 5, 5 zeros, and so on. Degree 1, 1 zero only. So linear polynomials, degree 1, na? So it is having 1 zero. Okay, na? Now, how to find out the zeros of this quadratic polynomial? So the concept is we need to divide the quadratic polynomial into linear polynomials. We need to divide the quadratic polynomial into linear polynomials. Okay, na? Then we know how to find out the zeros of linear polynomial. Now only we have seen that x plus 3, its zero is minus 3. So we need to divide this, or we need to bring this polynomial down to a linear polynomial by doing factorization. Okay. I think everyone knows splitting the middle term, na? Everyone knows splitting the middle term. That concept you know it, na? Only 24 members are joined out of 42. Children, you tell me why I have to continue these classes. So that much respect is there for studies. Even though it was only 24 students are joined out of 42. Your parents are not taking it seriously, and you people are also not taking it seriously. It was told to you clearly that these classes will have a link with the school classes. And I told you that I will stop these classes. But you are not accepting it. Now, tomorrow onwards I will not continue these classes. Yeah, 2, 6 are splitting the middle term. 2, 6 are 12. Now, we need to write 12 and the product of its factors. 2 6 are, 3 4 are, 1 12 are, minus 2 into minus 6, minus 3 into minus 4, minus 1 into minus 12. Dividing 12 by the product of its factors. Now observe the middle term, 7. So we can use these. 3 4s are 7. So 2x square plus 3x plus 4x plus 7 plus 6. So I am dividing the middle term into 2. I am splitting the middle term into 2. Okay na? Now first two terms I can take x common. Remaining is 2x plus 3. In the next two terms I can take plus 2 common. Remaining is 2x plus 3. So 2x plus 3, x plus 2. Now you can see Vaishali is there in the class. Vaishali, Komida. I am not getting answers from them. Vaishali, Komida. Ashish Babu also not there. Now, 0 of this polynomial minus 3 by 2 and 0 of this polynomial minus 2. So, minus 3 by 2 comma minus 2 are zeros of 2x square plus 7x plus 6. Okay na? So this process is known as splitting the middle term. This process of finding zeros is known as splitting the middle term. Okay. One more problem we'll see. x square minus 4 minus 8x. This is the polynomial and we need to find out its zeros. 5x square minus 4 minus 8x. So if you see this polynomial, it is not in the general form. We need to write it in the general form first. So how? Rewriting the polynomial with the 5x square minus 8x minus 4. Just interchanging the terms. Okay. Now, 5 into negative 4, negative 20. 5 into negative 4, negative 20. Okay. Now, write all the possible factors of negative 20. Once again, this is the given problem and it is not in the general form. We need to rearrange the terms, jumbling the terms. 5x square minus 8x minus 4. And after that, multiply coefficient of x square and constant. Multiply coefficient of x square with constant. 5 into minus 4, minus 12. Now write all the possible factors of minus 20. Minus 10 into 2, 10 into minus 2. 4 into minus 5, minus 4 into 5. 1 into negative 20, negative 1 into 20. So all these are possible factors. All these are possible factors. Okay. Now which is useful to us? Now see the middle term. Minus 8. Middle term minus 8. So minus 8 means this one is useful to us. Minus 10 plus 2. Minus 10 plus 2. So 5x square minus 10x plus 2x minus 4. So middle term is splitted. Middle term is splitted as minus 10x plus 2x, which is negative 8x. Now, from the first two terms we can take 5x common. Remaining is x minus 2. And next two terms we can take 2 common. Remaining is x minus 2. Again x minus 2 common. Remaining is 5x plus 2. So, a quadratic polynomial is drawn into a product of two linear polynomials. 5x square minus 8x minus 4 is nothing but this one, na? This is equal to this product of these two. A quadratic polynomial, it is drawn into a product of two linear polynomials. Now, 0 of x minus 2 is 2. 0 of 5x plus 2 is minus 2 by 5. 0 of x minus 2 is 2 and 0 of 5x plus 2 is negative 2 by 5. So, therefore, 2 comma negative 2 by 5 are zeros of 5x square minus 8x minus 4. Okay. Ashish Babu is there in the class. Ashish Babu is that girl. Vaishali, Govida. And even I can observe some boys also. K. Karthik. Shanmukhi is there in the class. Now I will give a problem to you. Find the zeros of this polynomial. Find the zeros of that polynomial. 8x square minus 4. What are the zeros? 2 Kartiks are there, na? 2 are there, Kartiks. Only one in the class. One more, Rehan Hussain is there. Rehan Hussain, what is his name? Rehan. I didn't see him also in all these classes. No, okay, leave it. Find the zeros of this polynomial. 8x square minus 4. It's a quadratic polynomial only. No, Rehan, he is not there. How to find out the zeros of this polynomial? Children, as I told you, this polynomial is like this. So x value is directly plus or minus root over minus c by a. Note down the formula. X value is plus or minus root over minus c by a. Okay. So here a is 8, c is negative 4. Substitute the values. Minus of minus 4 by 8. 4 by 8, which is plus or minus root over 1 by 2, which is nothing but plus or minus 1 by root 2. Plus or minus 1 by root 2. Means the zeros are, one is 1 by root 2, the other one is minus 1 by root 2. The two zeros are, one is 1 by root 2, the other one is minus 1 by root 2. Note down the formula, children. Finding the zeros of the given quadratic polynomial which is of the type ax square plus c. Ax square plus c type polynomial, quadratic polynomial. X is equal to plus or minus root over minus c by a. Just you need to take the values of a and b, a and c and inserting into it. Now you tell me how to find out the zeros of 5x square plus 10x. Third type polynomial. Third type quadratic polynomial. 5x square plus 10x. So how can we find out the zeros? Since it is a quadratic polynomial, it will have two zeros. It will have two zeros. Then what are the two zeros? Just we can take 5x common here. Remaining is x plus 2. Now 5x is equal to 0, x is equal to 0. X plus 2 is equal to 0, x is equal to minus 2. So 0 comma minus 2 are zeros of 5x square plus 10x. That means a polynomial of this type, out of two zeros, one zero is zero only. One zero is zero only. And the other zero is polynomial of this type. One zero is zero and the other zero is minus b by a. Note down this one, children. One zero is zero, the other zero is minus b by a. So here in this problem, a is 5, b is 10. So x is equal to 0 and x is equal to minus b by a. One zero is 0, the other 0 is minus b by a. b is 10, minus b is minus 10 by 5, negative 2. Okay, right? I think everyone is having R.S. Agrawal. Exercise 2A. Exercise 2A. Solve problems from 1 to 12. Solve problems from 1 to 12. Okay, na? We'll continue with this tomorrow again. Thank you very much. Dhanyawad.